right, so welcome to the OpenDaylight Mini Summit. Thank you all for coming. We've done a little bit different with the format here today in the sense that this is the first mini summit. This is a relatively new project, so it would kind of make sense to start with a full introduction of what the project is. But I opted not to do that given that this is also a very cloud-oriented event. And instead, the first session today is a panel, basically just trying to draw out all the issues right now that face cloud and virtualized environments, and what SDN controllers can do to help in that environment. So with that, I've got a panel here of experts across a variety of domains. I'll let them introduce themselves in a moment. But for those who may have found themselves in the wrong room, OpenDaylight is an open source project that is a collaborative project under the Linux Foundation, and it is a project to do an open source SDN controller. We started in April, and the first release is scheduled for early December. And you'll be hearing a lot about that throughout the day, what that looks like, a variety of the technologies that are in this first version of the controller in some level of depth. Again, I wanted to start off with just kind of get all the issues out as quickly as possible around cloud. So with that, let's go ahead and get the panel started. First, like I said, I'll have everybody introduce themselves. I'm not sure we need mics, but there, Chris, you get one regardless. So Chris, you want to lead us off?
Sure. My name is Chris Wright, and I work at Red Hat, the technical director for SDN there, and Red Hat is a platinum founding member of the OpenDaylight project. I represent Red Hat on the board and the steering committee. So I spend all my time thinking about SDN network virtualization.
So my name is James Bottomley. I'm Chief Technology Officer of Super Virtualization at Parallels. Parallels is a company that specializes in serving the needs of service providers who want to give virtual private environments to end customers. So people like GoDaddy and MediaTemple. If you buy a web service from GoDaddy, chances are it's running on our virtualization technology. My ultimate goal as Chief Technology Officer for Server Virtualization is not to have to worry about the damn network at all, which is why I'm here to explain some of the problems that we see in networking in the cloud and how I just want somebody else to make it go away.
Hi, my name is Chirali Bhutan. I am a contributor and PMC member of Apache Cloud Stack. I also work at Citrix, who's a platinum member of OpenDaylight. And my goal here is to explain the problems we see with cloud and what we hope OpenDaylight will solve.
Hi, my name is Kyle Mestry, and I work at Cisco, so I feel perhaps I should apologize to James maybe for network issues he's facing. So I'm a principal engineer in the office of the cloud CTO working on OpenStack. Cisco is also a founding platinum member of OpenDaylight as well. So I guess I'm here from the OpenStack perspective as well to talk about the needs of cloud infrastructure service on SDN.
I'm Dave Meyer. I work at Brocade. I'm CTO, Chief Scientist, whatever that means. Brocade is also a founding member of OpenDaylight. I'm also the chair of the technical steering committee for OpenDaylight, so we kind of try to build, kind of steering. It's really about steering the project. But one of my goals here was I'm hoping that this will be a very interactive session because I want to hear more. I want to learn from you guys, basically. So I'm glad to talk about anything that anybody wants to talk about around OpenDaylight or networking, even as hideous as that is. But I hope to learn from you folks.
Very good. Thanks, guys. And so, yeah, I've got some kickoff questions, but I'm really hoping that most of this panel will be driven by you folks. All right, so be thinking of your questions as we get kicked off here. Kyle, I'm going to start with you. Just from your environment within OpenStack, what do you see as the main issues today in dealing with networking from an OpenStack implementation?
So from That's actually an interesting question. So OpenStack has been, I mean, as far as networking in OpenStack goes and how we integrate with different things, OpenStack originally had Nova networking, and for the last 2.5 years, we've been working on the project formerly known as Quantum, now known as Neutron, which has kind of been this grounds for all of the networking people, whether it's vendors or service provider users, to kind of collaborate on networking inside of OpenStack. So, you know, we've had the last 2.5 years to kind of get to the point where we are now, which is the Havana release, where Neutron has added additional functionality and things like that. And kind of what we've seen in Neutron, I think, is we've seen additional complexity kind of being added inside of Neutron as more vendors come in and more things are added in. Even the open source plugins, the Linux Bridge and OpenVSwitch are, you know, have more complexity being added to them and things. So one of the interesting things that OpenDaylight will provide for us when we integrate that with OpenStack Neutron is we can effectively pass API calls to OpenDaylight, and we can, maybe I shouldn't say it, we can move the complexity to OpenDaylight, perhaps is what I'm trying to say. But I mean, by doing that, you know, OpenDaylight can then provide things like tenant scalability, virtual networks for the tenants, all of these types of things. And I think it's actually a nice model there. Effectively, Neutron is an API server at that point. So.
Very good. Charity, same question, except from the perspective of CloudStack.
Sure. So CloudStack has been around a little longer than OpenStack. In the first release of CloudStack, we invented VXLAN before it was called VXLAN. We did the whole multicast thing, and we found that, you know, switches wouldn't scale with the multicast. And so then we switched to VLAN, and then we had customers or users hitting the limits of 4K VLAN within a few months. And so then we invented a handled our own GRE-based overlay solution. So we have a lot of experience with network virtualization, but we'd rather not do it, leave it to the experts. So that's one thing. Network virtualization is probably the biggest pain point for some of the larger clouds out there. The second thing is that, again, based on customer usage, CloudStack has been rolling a lot of point integrations with either physical network equipment or higher up the stack, layer 4 to layer 7, and doing a lot of service chaining and things like, you know, should the firewall be in front of the load balancer, should it be side the load balancer, should the IPS be at this point in the network. So we're doing a lot of problem solving in that arena, but I don't think that should be a core focus of cloud orchestration, and I hope that software like OpenDaylight will provide the solutions in this area.
So actually, that actually brings up an interesting point. I mean, a lot of the stuff you're talking about with regards to service VMs and service chaining and things like that in these cloud things, I mean, that's going to be the same ultimately, whether it's CloudStack or OpenStack. So rather than having both of the projects implement what effectively would be the same solution to an end user, it makes sense to move that to a common project.
Absolutely.
Very good. Good. Pass the mic to James. We'll give him the opportunity to ask for SDN controllers to remove all of the complexity for him, so he doesn't have to think about the network. In essence, that is the question. So talk to me about the pain points that you see in CTO Parallels, a very large cloud provider. What are your hopes for SDN controllers to make that all go away?
Okay, well, the first thing is to understand actually what the problem is. And so, if you remember, we serve the service providers who provide cheap virtual environments. And most of the time, most of their customers just want one virtual environment running one web server, and the network isn't really a problem. The problem comes when you have more sophisticated customers who buy more than one virtual environment, and they have this unreasonable expectation that the two virtual environments they bought will be able to talk to each other over a private network. It sounds like such a simple problem. This is a problem that everybody here has been trying to solve for the best part of a decade. And like you, we thought the first solution was VLANs. I am incredibly, I'm in fact gobsmacked that you managed to get it up to 4K, because what we found is with most switches, the cock-ups in the spanning tree protocol mean that once we go beyond sort of trunking of about 100 VLANs, the switch itself falls over. So VLANs were a complete non-starter. Not because, I mean, we didn't even get to the point that they were so stupid they only put 10 bits in the protocol, 12 bits in the protocol for the number of VLANs. We got to the point the implementation was sucked by the time we got to 100 networks, and it's unscalable enough. Once you get more than 100 customers trying to do a network, which you think about these service providers, they want to rack of 64 systems, they want to hack virtual environments on their systems in densities of around 100, and they want to provision multiple racks, so we're talking about tens of thousands of virtual environments, and even just a few hundred customers buying 10 virtual environments already gives beyond your possible scaling experience. So right at the moment, we are running with a hand-built solution where we basically fiddle the layer 3 routing table to try and get these virtual environments to work with each other. And what I want out of this is an assurance that give me a solution that actually works and is scalable and doesn't cock up in exactly the same way that VLANs cock up. I believe that's sort of the promise of OpenFlow, and so I'd actually like to see you deliver on a scalable way. The word scalable there is non-negotiable. Does that cover the basics of the problem for most people? I mean, this isn't getting into, we like to control the flow of the networks, and we like to provision bandwidth, and all of these other things are nice to have. Fundamental is I have to get two virtual environments talking to each other in private network. Solve fundamental first, do the fancy stuff later.
Very good. Thanks, Dan. Chris. So similar to James, but you work for a tech vendor that's delivering solutions for a variety of virtualized environments. So I'd like you to talk a little bit about what you see from your customers' perspective as what issues they're seeing with networking, particularly in virtualized environments, and how that might apply to OpenDaylight and SDN.
Well, it's actually pretty simple. We have basic problems with all the orchestration systems trying to allocate private networks on behalf of users in any scalable and real-time way. All of the solutions that we have are either directly coming out of an orchestration system like OpenStack, CloudStack, or for Red Hat, that would be OpenStack and Red Hat Enterprise Virtualization. We're limited, like James said, by VLANs as not only fundamentally bit size limited, but scaling limited once you trunk it. VLANs are a really nice solution to a real problem, and then trunking all VLANs on a single port is undoing everything that VLANs gave you to begin with, so it really is a non-starter. Completely agree there. So our customer pain points are simply, we can't do these things very well with the tools that we're given right now. So our interest in building an SDN controller is to solve those problems. So how can we quickly and scalably build out virtual networks for users in cloud systems or virtualization systems? There's a lot of intricacies, and is it OpenFlow, or is it this encapsulation format or that encapsulation format? Are you using overlays, or are you talking strictly to hardware? At a certain point, those are all implementation details, and the real question is, do we have a system that can manage all the relevant infrastructure? Our particular focus point is on building up most of the intelligence in the edge virtual switches and managing that centrally within SDN controller. So that's kind of where we're coming from, and that resonates best with our customer requirements. But there's a lot of ways to solve the problem as well.
Thanks, Chris. Please pass the mic down to Dave. So Dave, you're the most tenured, most mature industry technologist on the panel. So I just wanted you to just kind of talk about what you've seen as networking has evolved and as virtualization has really taken off in cloud environments, and they continue to evolve. What do you see as the most important points for the networking industry to react to for those environments?
Yeah, that's a good question. Well, I was listening to the answers from the rest of the panel, and one of the things that really struck me was people talk about scalability, right? And scalability, obviously, we have to have scalability. And one of the really great things about, the internet is that it's clearly pretty scalable, right? The data centers and that stuff, maybe not. But we also have to have evolvability, right? We want to be able to roll out new services, things like that. We have to be able to evolve too. So scalability and evolvability kind of go together. And if we build a scalable system that's ossified, we're probably not going to be happy with that, right? And predicting the future, especially when it's in the future, is pretty tough. So, we want to build scalability and evolvability at the same time. So that's one thing that I think people kind of forget sometimes, because we're really focused on, just like James was saying, okay, we have, are you talking to Igor or something like this, and we have 100,000 VMs in our thing, and we have to be able to move around that to get all this stuff, right? Well, that's what we're doing today. But in the future, we don't know what we're going to be doing. So we need to build an architecture that's also evolvable. So what I'm arguing here is that as an industry, we kind of look at it as scalability as the most important feature, and it is an important feature, don't get me wrong, but we also need evolvability. And the other thing that struck me from what the panel was talking about is the entire use of the term virtualized. It's like, this is networking. We used to not have this kind of networking, but this is networking, it's just a layer, right? And so maybe and this occurred to me while everyone was talking, is that maybe one of the things that we need to do is conceptualize architectures as architectures, and not as some kind of special purpose virtual thing. Because nowadays, what isn't virtualized? What isn't virtualized? And if you look around and you start thinking about it in terms of layers, you could actually say something like, the IP layer virtualized the underlying transport layer, right? And you can say that the transport layer, the TCP layer, or anything above that, virtualized what was below it. And so maybe what we need to do is have kind of a more general architectural vision of what we're doing to unlock some of the potential and solve some of the problems that were just discussed here. Now, I did want to say one thing, and James mentioned the OpenFlow. OpenFlow is a great thing, and I'll tell you, Nick, Scott, and Martine did a great thing by, kind of bringing to everybody's consciousness the fact that we need the network to be programmable. Whether or not OpenFlow is a general purpose technology or not, or if it's a special purpose technology, that's really less important. So network programmability is what we're after here. And I think that, the OpenDaylight, what we're trying to do is build a platform that provides not only scalability and evolvability, but network programmability. And so if we can do that, I think we will be successful.
Very good, thanks, Dave. Folks in the audience, questions? Gentleman back here.
Hi, my name is Gilad. I work for a hardware vendor, networking hardware vendor, EasyChip Technologies. As someone who's working to make the sort of chips that are being used in the switching and routers that you guys complaining of how difficult the program, I really want to ask you, what would be your wet dream for how to make to put in his chips so you would be happy?
Why am I answering this question? What I really think is that, I've looked at a lot of designs, I haven't looked at EasyChip recently. When I was back at Cisco, we did a lot of work with EasyChip, but, and there's all these other radical designs. I don't know if you've seen again, this is Nick McEwen and his colleagues at TI. Did you see the paper they presented at SIGCON?
What was the name of the paper?
I forget the name of it, but it's about, we have giant TCAMs that are reconfigurable in this way. Because, the OpenFlow, these are OpenFlow people, right? So they have this match action table semantics, and they want giant reconfigurable TCAMs, right?
Okay.
From my perspective, I kind of look at it that, in-cap, decap's important now. And, it took a while to get DTAP and things like that into hardware, and we need that stuff. But generally, I'm of the opinion that, with the exception of these special purpose kinds of encapsulations, simpler and faster is better. Right? Basically, at the end of the day, we need to kind of forward IP packets as fast as we can, and probably MPLS, you know. But that's the way I see it. And I remember, I don't remember the exact statistics, and I don't know if it's something I can talk about, but I remember when Arrow Lake was being built, there were all these features, you know, and you know, that I don't know what percentage of the die, maybe you remember this, but some large percentage of the die was really dedicated to features that really weren't used. You know, it's basically not a lot of the features are used in these chips, right? I don't know if it's the case for Easy Chip because it's, you know, I don't know, it's a, you know, but in the case of A6. So, forwarding IP packets fast, I think is the answer.
Yeah. And I think what goes along with that, as far as having, you know, the switches and stuff, be a big fat IP pipe, so it can carry IP packets and MPLS, of course, is, you know, you look at some of the services that you may want in your network and stuff, right? And I'm not saying there's not a place for that in hardware, but in this type of virtual environment where you have tens of thousands of tenants, you know, hundreds of thousands of servers and things, do you want those services to be static, or do you want them to be virtualized in software, right? You want to be able to move the services around. I think there's a case for both cases, but certainly, you know, in that type of environment, you may want your network services to be in software.
It's a great point that Carlos makes, but the other one that I wanted to add to that is that stuff, you know, we're in the software world, you know, and everything's software, right? And we're happy about it, right? But it is the case that stuff flows back and forth across the hardware-software boundary, you know? And when there's a need to have optimization that you can't get out of software, then we try to get it in hardware, and that's just the history of how this works. I think, go ahead.
So I have a question regarding this. So people keep doing this distinction between, you know, hardware, like the chipset, Easy Chip makes it, and software. But would you, as software people doing networking, really care where your software is running? I mean, does it matter to you if it runs on the x86 or ARM, or if you have a programmable, let's say, network processor that you write in C under Linux and it just forwards packets? Would you consider that software? Or
So I think there's two perspectives, right? I mean, as the user or the tenant, I don't think they care.
no,
They just
obviously,
right?
for the guys building the networks.
Right, even as developers, I mean, does it matter? I mean, x86 ARM versus a chip, I mean, really, it doesn't matter. I think it's like Dave said, if we can take advantage of offloads to make things faster, I mean, as the packets are flowing through the network, then we'll do that, and then I think that's where it makes sense.
Excuse me. One other thing on that is that what is hardware and what is software? Once you have an NPU, what is hardware and what is software?
But that's exactly what I was relating to. So obviously it needs to be easy to program, so it won't be a big headache. But once you have something which is easy to program, which is hardware because it's NPU, do you care? Would you like to use something like that to just push, I don't know, uplets?
Yes. One thing we'd like to push down is more virtualization into the hardware, like when we do today, when we do GPUs, for example. To take a similar example, quite often the number of virtual functions are limited, or you have to do it in software to virtualize the GPU. So if there was more support built into the hardware, in the NIC itself, to have hundreds or thousands of virtual functions, that would be great. The second part is that we have a lot of experience talking directly to physical devices to configure them. And one thing that's missing is idempotency. So quite often we don't know whether the rule set we have pushed down to the hardware actually took. So we'll do it again. But whether that is idempotent or not really depends on the software implementation, which in turn might depend on how the ASIC registers are programmed. So something to think about when interfacing with your software colleagues is how you provide idempotency to the orchestration system.
So you want to know what kind of rules are in
Exactly, yeah. Or if I push the same rule again, you say, I got it, you know.
Okay, so for me, the idea of network vendors trying to differentiate at the switch level with features sends shivers down my spine, primarily because as somebody who serves people who are, to put it politely, cost conscious, you're adding cost to the networking layer that they're not going to pay for. And conversely for me, this means that the only way I can roll my product out to my customers is if it works on commodity hardware. And that means that any features that you add that differentiate your switch from your competitor switch are useless to me because I'm not going to use them. So the features that I need to be commodity and I need to be standard in every switch, because otherwise I get myself into this situation where I sell a customer a massive network rollout, they have Gen 1 of the switch instead of Gen 2 of the switch, they roll out the switch, it fails completely in the marketplace and I get blamed for it.
So that was an interesting description of what I was calling evolvability, right? The reason why you can build new things on top of this commodity stuff is because it's actually like, if you've seen the internet hourglass, that thing makes a waste that you can build all this stuff on top of, right? This turns out to be an architectural principle that we need to maintain while we're doing all of this stuff. And you just gave a business reason for it, but there's actually an architectural thing underlying that, which is that these architectures that are evolvable and scalable have this hourglass shape. Or if you're a biologist, they turn it on the site because they see layering as horizontally instead of vertically, and actually they call it a bow tie. Those are biologists.
So I'm fine with adding features, but it has to be standard, you all have to agree. If you differentiate them, just not going to use it. And it has to be cheap, of course.
And if not standardized, maybe abstracted to the level where, again, you don't care.
Well, yeah, good, exactly.
Other customers?
My wish list includes easy software programmability. That's both at the at protocol level, whether it's OpenFlow or something else. I think match action is overly restrictive for certain, for routing, for example. It works well for layer 2 switching and layer 3 switching, but I think there can be better interfaces to manage the ACL, the TCAM entries, and the chips that would be accessible to software remotely, and for people building Linux to run those chips directly. Please don't make a horrific SDK.
There's one more thing. I actually want it to work, so I don't want another VLAN cock-up where I try and explain to my customers that, hey, they can only use 4K networks, and in fact, they call me on the phone when they just got up to 100. That's no longer working.
All right, last comment.
Yeah, I just want to summarize for you what I heard here. Just make it better, faster, and cheaper.
Yeah. Programmable. They forgot programmable. Yeah, thank you.
You tend to when they are working in the like community hardware, open computing, when they have open networking hardware, you have a plan to work on.
Do we have a plan to work on that? Is that the question?
Oh, yeah.
Is the question, do we plan to work with the Open Compute project?
Yes.
I don't know of any formal relationship that's been started, but certainly I think OpenDaylight wants to run on whatever's out there. It should be, if it's successful, it's going to be agnostic to whatever's underneath it, either physical or virtual. Anybody else take a lot of that?
There are a few folks who have from the OpenDaylight community who've expressed specific interest in Open Compute and the networking platform there. But I think, like Dave said, it's really about we're building infrastructure that's programming switches as long as they're either compliant to OpenFlow or providing some kind of a plug-in into the OpenDaylight controller framework to manage themselves. We're not that picky. Our goal is to grow, build an ecosystem around the project that allows us to get a bigger development community and a bigger user community. So if Open Compute is up for working well, OpenDaylight, we're up for it as well. And I don't see I don't think we're at odds at all.
So just as a technologist, I'm sort of always interested in technology, but serving the business needs of the company whose services are a marketplace that's entirely based on commodity. Something like Open Compute is very leading edge, and it will take a long time before it passes into the commodity cost which my customers are looking for. So I'm happy to play with it, but I wouldn't be ready to roll out products on it if years, I would say.
Thanks. I just want to make a comment on what the target network, if you will, is for OpenDaylight. And I did say that it should be, we want to be able to have, a control platform, a networking platform that can use both physical and virtual networking devices, but it's not limited to switching. So I kind of envision you might be able to, that we'll be able to control both virtual and physical network appliances of all kinds, right? And then we can integrate that into a sort of a more common data model, environment where we can really understand, where the users of that environment can really understand in a nicely abstracted way what's going on in the network. Even if the devices aren't, traditional routers or switches, maybe they're load balancer, just firewalls, IDSs or whatever, but virtual or physical.
Yes.
Yeah, I have a question that kind of keys up what you just said. So I work on database clustering, and one of the things that we like to do is have a bunch of replica databases that look to applications as a single server. So we've been very interested in layer 7 routing for a while, and I was just wondering given the types of problems we'd like to solve involve things like being able to load balance between sort of very, very quickly between database copies, being able to take things transparently offline by dropping routes or otherwise making them inaccessible, and then bringing them back. There's stuff that's in scope. Is that kind of problem in scope for what we're trying to achieve?
So we don't have any projects right now that really, well, I mean, there's some things in OpenDaylight that are, actual projects, like there's this thing called the Affinity Metadata Service, right, which has some of that flavor to it, right? But I don't think it's necessarily out of scope. We just don't have any real projects that are exactly like that have been proposed yet. Although that would be interesting to see if we could.
Because it does seem like there's this whole, at layer 7, you're starting to get into the apps, and like in our case, we're looking at the wire protocols for, say, MySQL, Postgres, name a database we're interested in, but it seems like there's a lot of other apps that are going to want to be making routing decisions based on things that are going on in the protocol. But for us, the switches have been this kind of closed, they've been off limits, we have to wait 2 weeks for somebody to do anything. So we're very, very interested in opportunities to be able to get in and program that stuff correctly.
So what you're actually talking about in cloud terms is this thing called horizontal scaling.
Yes.
So right at the moment, most clouds are sort of vertically scalable, which means you can add and take away resources from virtual environments running on a single system. But as we expand into the application space, we will see a time when you'll actually want an application to replicate itself across multiple physical systems and then be able to load balance the top of it.
Yeah.
Right at the moment, to achieve that architecture, we use something called the Linux Virtual Server, which is a way of actually routing packets from one to the other. What you're actually asking for is an implementation of LBS inside the switch, right?
Essentially, yes. And I mean, we're looking at things like HA proxy and LBS too, and I'm just wondering if there's a connection between, if that stuff is going to be folded in at any point.
So right at the moment in the industry where we are is that almost everybody is struggling towards vertical scaling. The number of people who are considering horizontal scaling is not zero, but it's small at the moment, but it will be growing. So this problem looks to be sort of after you solve my VLAN problem, this will be the next generation problem.
I'm hearing that. Thank you.
To answer your question, actually, in a slight twist, OpenStack, for example, the Neutron networking service has a notion of load balancer as a service. So there's this concept of L427 services that you can insert into the network. Absolutely in scope for something that Neutron isn't actually providing the functionality. It's sort of kicking out elsewhere to do the orchestration, and to have that done by OpenDaylight is 100% within scope. It's just like Dave said, we don't have anyone doing it. So you look like you're a good volunteer.
Yeah.
It's wiki on OpenDaylight.org. Come on down. Come on over.
You're doing a session at 3, by the way.
Let this guy have a
Yeah,
chance.
so yeah, the gentleman in the back.
I'm not sure it's just about horizontal scalability. So a vertical scalability case where you want sort of layer 7 decisions into this would be a case of a virtual desktop infrastructure where you've done some brokering and you've decided who needs to talk to who. Why not be able to push that information about the flow down to the switch preemptively rather than waiting for the flow to begin and then have the latency hit at the beginning of the packet flow. So, I mean, that to me is still vertically scalable. I've got a bunch of machines, I want to get more capacity, all that sort of thing, but I still want some layer 7 influence on that.
So again, it's absolutely in scope, and it's an interesting discussion that we have in the OpenDaylight community about the controller is kind of generic, doesn't have a prescriptive way that it defines how you manage the network, and there's bookends of the spectrum of purely reactive and 100% proactive in terms of how you push flow table entries. I mean, personally, I think the open flow model suggests a more reactive mechanism, but it doesn't require it. I'm in a virtualization orchestration system where you know ahead of time where you're putting things. I think it makes sense to proactively push flow table entries, and so now we have 2 people who are coming.
Yes, we're going to
Trying to figure out why we've invited you here.
It's an official subcommittee now.
Next question. Yes, sir.
So my question is about how to make network more programmable. So up to now, at least I saw couple of approach there. Like first, the startup Cumulus network. Those guys try to bring the Linux as the network OS inside the box. So they try to leverage the Linux ecosystem. So the second is like system. So they try to open some capability with one people. So the last one is like OpenDaylight. So try to take out some intelligence out of the box, leverage the software technology. So could you guys comment with different approach there? So how to make the network more programmable?
I have an opinion I'll offer real quickly. And I'm not sure I completely understand your statement and question, and I'll explain why. Both Cumulus and 1PK are potentially manageable by a system like the OpenDaylight controller. And in fact, Cisco's trying to work to make OpenDaylight work with 1PK. So I don't think that these 2 concepts are at odds. I think that they work together. So you may have an environment where you're using centralized SDN controller to manage either commodity-based, Linux-based, Cumulus-style switch or traditional Cisco switch. The question that you asked about how do you make it more programmable, I think is the interesting one, and that's sort of defining what are the guys that we care about. And it's well understood in an operating system what the primitives are that you need to offer an application to manage the resources that the hardware are providing for you. I don't think we have as good an insight yet in the SDN space to know what are the right APIs to provide to applications that really make the network more programmable. I think that that's one of the things that we'll discover through the process of developing OpenDaylight.
I'll take it first, Joe. So, just from a point of view of what we're trying to supply to our customers, the job of a company like ours is really to provide power while hiding complexity. And the thing about a programmable network is it's definitely increasing complexity. I have no customers today, but standing up and down and waving around their flags saying, "Oh, programmable network, I want a programmable network." They have a set of problems they want me to solve. So the question I ask myself is, would a programmable network allow me to solve those problems? And I look at everything through that grid. So I'm not really interested in providing a programmable network to my customers. I'm interested in using a set of tools that provide to me to wrap it all up so it hides the complexity from them while providing them the power to do what they need. If that sort of helps frame the context of the question you're asking. So I think, for me, as a supplier of power without complexity, a programmable network might be useful. Providing a programmable network to my customers and allowing them to shoot themselves in the foot with it and then call me for support is a nightmare.
So I think there's two ways to kind of look at this. There's the current way that people are looking at network programmability, right? And I think everyone will be shocked to realize that people that are developing that and doing it are all networking people. So everything looks like something a networking person would want. I don't think anyone's really looking at this from the perspective of what do the application people want. So as a result, what you're seeing with the current generation of controllers, whether it's NSX, or whether it's OpenDaylight, or whether it's Ryu or any of these things, is they all look like a network person designed them, right? So I think that's generation one of where we're at with regards to network programmability. I think if you look at where we're going to be 5 years down the road, at some point the application guys are going to start to have input. And in fact, as OpenDaylight, I think we'd love for the application people to come to us and start to work with us, because we need to start thinking in terms of applications. And perhaps this gets back to the horizontal scaling versus vertical scaling to some extent, right? But clearly I think we have a lot of work to do, and we as a networking industry around how do we make applications work better, and how do we enable that? So.
I think the other thing that OpenDaylight, I wish OpenDaylight will focus on is, unlike a POS API, which is a single system API, OpenDaylight and SXX, these are distributed systems APIs. And there's two ways of approaching a distributed system programming. You can either hide the complexity, saying that everything is strong and consistent, or you can push some of the problems to the application writer. And so I'm hoping that OpenDaylight will solve some of those very hard computer science problems for the application programming.
Very good.
There is actually a third way of looking at a distributed system, which is not either trying to hide the complexity or alter the applications. It's where you separate the problem into two planes and decide what is relevant and what is not relevant. If you can ignore all the irrelevant stuff, you can use what remains of the minor control plane to actually provide power to your users. The main problem is when they start getting hung up on all the irrelevant stuff. So it's actually failing to look at the problem in the right way is a lot of what provides complexity in distributed systems. So we actually need better and newer ways of looking at the problem as well.
Very good.
Okay, so let me extend a little bit the question of the previous gentleman. What's the relation of OpenDaylight with OpenContrail? Because the latter is actually exactly what James was asking for, simplicity for virtualization of tenant internet-working.
So I don't know this, I'm going to hand it to one of the experts. Who does?
Oh, great.
Dave knows everything, so.
Yeah, thanks a lot. Appreciate the question, Robert.
Yeah.
So, I mean, I have to say, I think that I agree with you that the open contrail architecture is pretty elegant, right? And OpenDaylight has worked a lot with Juniper. We haven't had them come to us and say we're going to bring Contrail into OpenDaylight, although we like that, right? So I'm not sure how that's all going to play out since they just launched that open Contrail stuff. But their solution is elegant, and it'd be great to have it in OpenDaylight as well. So I don't know, but right now they have their, I'm not sure what their business, interests are and how they're going to play it out. But they haven't come to us. I will say that originally, the original representatives to OpenDaylight from Juniper, Ken, Tom, and Benson, did want to bring Contrail into OpenDaylight, and whatever their internal business practices were, that couldn't happen.
No, because both can independently exist, right? So if you remove all the open flow things, the open Contrail, it's what's really matter, for example.
Yeah, but, one of the things about that is that I think we've been talking a lot about complexity and things like that here, and I think if we start having a lot of different systems managing different parts of the same infrastructure with different data models that don't communicate. And we already have that, by the way, with, I think, to some extent, we'll already have that with OpenStack and OpenDaylight, and they already have that with OpenContrell and Neutron, right? So they have different data models for the same thing, and they don't communicate, right? So I think we want to solve that problem as well. And so I'm hoping that we'll be able to get at that. That's a kind of a bigger problem, but at the same time, I think it needs to be solved. So in the context of OpenContrell and OpenDaylight, it'd be great if we could bring these two projects together. I don't know if it'll happen. We don't know.
One more question. We have time for one more.
What's the solution? I mean, there's no action to fix a lower layer problem with a higher layer solution. It's very difficult. VXNet, 82.q1q, GRE, these are all higher layer solutions of encapsulation of a layer 2 issue like your VLAN problem. We have 4,000 VLANs. Some devices can't do, a lot of devices can't do more than a couple hundred. But what's the solution? We feed horizontally, move horizontally across the hardware. Do we need to rebuild the layer 2 protocol? No.
I hope not.
Back when these things were designed, you had one physical machine has one physical address. Now you're looking at one physical machine having 100 addresses. When you look at Ethernet.
Yeah, so when you're talking about addresses, presumably you're talking about... MAC addresses, yeah. I don't think that the solution to any problem should be expanding L2 or adding new L2 protocols, right? I mean, maybe we should look at it reverse and see how far we can push L3 down, right, and go that route. Because
that's what GRE effectively does.
Right, exactly. But again, whether it's whatever it is, GRE or VXLAN or whatever the next protocol soup thing you come up with, right?
But we keep on coming up with new encapsulation techniques that just do the same thing. Is that the solution?
Oh, I don't know. Clearly, that's not the solution either, right? But I think that in the context of L2 versus L3, I mean, I think you want to simplify things and go with scalability, you want L3.
Just to raise the question you put up to an architectural level, what we're talking about in the cloud is effectively an overlay network. Whatever we call it, virtual networking, whatever, we're talking about trying to do an overlay network based on top of some sort of physical topology that our customers set up. A lot of our customers are not polite enough to set up an L2 routable technology, so a lot of it has to go over L3. This is why we get into solutions like GRE. And basically, because we're trying to do what's a virtual overlay on top of a physical network and pretend that our virtual overlay is that network, I don't see us getting away from encapsulation anytime soon. What OpenFlow tends to promise in terms of doing this is just that we actually make the networking infrastructure understand the encapsulation and therefore make its decisions more efficiently. That sounds, in the context of the problems, to be about the most efficient way to do it, unless the network guys have anything more to add.
Sometimes I think if the VLAN ID was 16 bits, perhaps it wouldn't have an SDN industry.
So still top out of 100.
Yeah. The one thing I could say about the encapsulation stuff is that it's kind of a general paradigm. It's like layering, right? Encapsulation is like layering, right? And layering is how we can do abstraction and how we get scalability. So I think encapsulation, we think about encapsulation, we think about, GRE or something like that. But actually, your data is encapsulated in an Ethernet frame. The Ethernet frame is encapsulated in an IP packet. The IP packet has a UDP or a TCP header. It's all encapsulated. There's nothing that's not encapsulated. So, in a way, it's just a general piece of that. Again, like you said, like virtual or overlay networks. I think we've got to get away from thinking of it that way. It's just networking. It's the way we do it. And there are different problems when you're not running right on the bare metal, but it's just networking. So I don't think encapsulation is going away, anytime soon. And I'll just say one thing about the OpenFlow thing. OpenFlow effectively delayers the network in the sense that you can match over whatever number of bits of the header, that you want to. There's no the network doesn't know about layering in an open flow case. And you can ask yourself whether or not that's a good or a bad thing, or whether or not that confers properties that you want, like scalability and vulnerability. And, that's another discussion, but, if you think about OpenFlow itself, it really is a delayering technology, not a layering.
All right, we're out of time. The next session is going to go into what's in the first release and an introduction to what OpenDaylight is in more detail. So come back for that. But for now, thank our panelists.